Alright, 7th grade, let's start lesson 1, which is based on complementary and supplementary angles. So our aim for today, how do we solve for missing angles in word problems and diagrams involving complementary and supplementary angles. And of course this video goes along. If I'm going too fast and you can't keep up, you can always hit the pause button. You can always rewind, right? Okay, so let's jump right into it. Today's video should be, I hope, a little bit of a review. You should have gone over these terms before. If not, that's okay, as we're going over it now. But some of these terms may seem familiar. I hope they do. So our first definition here, I'm going to read it to you first. I want you to give you a couple seconds to think about it. Try to think of what the word might be. So our first guy here, two angles, angle AOC and angle COB, with a common side of OC are blank angles if C is in the interior of angle AOB. Okay, so these are basically two angles that are right next to each other. You might have heard this word before, I hope. Well, it's not the next two angles. These are called adjacent angles. Okay, so I hope you've heard that before. Adjacent angles are usually right next to each other, and they always have a common side. You can tell this because, again, it says right here the common side of OC. And if you look at the two angles, look at this right here. They have OC in common there, and they also have OC in common here. Both letters are, I see that the letters are switched to the second angle, but they are still right next to each other, and they have the same letters. So that makes those adjacent angles, they're right next to each other. Okay, and then you can also throw this word right into that spot right there. Okay, so those are adjacent angles. Let's look at our next definition. When two lines intersect, any two non-adjacent angles formed by those lines are called blank angles, or blank angles. Now these are angles that are, you can say they're right across from each other, they're opposite. I like to think of these as the bow tie angles, because when you draw the two lines, these two angles kind of look like a bow tie. We'll look into that next. These are called, give you enough time to think about it, these are called vertical angles, or vertically opposite. Okay, so our vertical angles are always opposite from each other. They are not adjacent. They will not be right next to each other. They'll be opposite each other. We'll take a look at this in our next slide. So again, vertical, we'll plug him in that box right there, and then obviously vertical opposite, two words, 1, 2. Okay, so again, these are some key terms that we should be reviewing. Our last one here, two lines are blank if they intersect in one point, and any of the angles formed by the intersection of the lines is 90 degrees. There was a special relationship when two lines crossed and they formed a 90-degree angle. I hope you've heard of this before. Two segments or rays are blank if the lines containing them are blank lines. And these are not parallel lines. These are perpendicular lines. Again, perpendicular lines are ones that when they cross, they will form a 90-degree angle, and that's going to be important today. You have to know what a perpendicular lines are. Again, fill these guys in the blank lines. If you need time to pause the video to write down the rest of the notes, you can, but I'm moving on. Okay, here are some angle relationships. We have the statements, we have the names, and some illustrations. So let's take a look at it. We talked about these before. These adjacent angles. If we take a look at the diagram, the illustration here, this angle A right here. Here's angle A. And then we also have this angle B. Okay. And when we add those up, it'll give us this whole angle right here of angle C. So when you add the two angles together, those that one's right next to each other, it'll give you a new measurement, the entire angle. Okay, so the abbreviation here, angle S adjacent. Okay. And the measurements of the adjacent angles add. Okay, so here's a little statement about it. When you add A and B together, like we just said, you'll get that C, that angle C. So there's not an expression, that was an equation right there, and we might need that later on. Let's look at vertical angles here. We talked about these before. I kind of hinted that I call them the bow tie angles. If you look, this right here kind of look like a bow tie. See if my coloring skills are still good. I don't know. It kind of looks like a bow tie to me. I don't know if I fill those in. I just call them the bow tie angles, but those are called vertical angles. Opposite each other, here's angle A, and it is opposite angle B. Now if I matched angle A with this angle here, that would be an adjacent angle because they're right next to each other. But we're not talking about that here, so we'll get rid of that. So angles that are opposite each other are called vertical angles. Again, vertical angles, vertical angles have equal measures. So if they have equal measures, we can say that angle A is equal to angle B, right? So A is equal to B. Okay. And we have our angles on a line. Okay. Angles on a line, that's our abbreviation. I hope we can remember, let's see if you do, how many degrees are on a straight line. I'll give you a couple seconds to think about that. If you read the statement, you might find out. So I'll read the statement to you. If the vertex of a ray lies on the line, okay, and if you don't remember what a ray is kind of like a line, but it only goes on forever in one direction. Not the band, just a line. Notice this guy right here just keeps on going up. It doesn't go backwards. So again, if the vertex of a ray lies on a line, but the ray is not contained in that line, then the sum of the measurements of the two angles formed is 180 degrees. So, you might have heard this before, that a line angle has 180 degrees on it. Well, if I cut that line with a ray, I'll have two separate angles here. I'll have that angle A again, and that angle B. Okay, well, first of all, my first question is, are these adjacent or vertical angles? I hope you said adjacent, because yes, they are right next to each other. And then look again. Here's another reason why, if you didn't know, that a straight line has 180 degrees. If I was to draw a circle around these two angles, well, it wouldn't be a full circle, it would be a half circle. For those of you who know anything about skateboarding, if you go halfway around when you do a jump or a spin, that's called a 180 degree turn. Well, the same thing here, 180 degrees. Our last one here is angles on a point. Abbreviation, angles at a point. So again, suppose, I'm sorry, I forgot to tell you about angles on a line, the statement here. When we add those two angles together, we get 180 degrees. Okay, so let's suppose three or more rays with the same vertex. I'm going on to angles at a point. Suppose three or more rays with the same vertex separate the plane into angles with disjointed interiors. And the sum of all the measurements of the angles is 360 degrees. Again, here's angle A, that's part of a circle. And here's angle C, another part of it. And then lastly, angle B, again, that's a pretty bad circle, but it is a circle, and you should know that there are 360 degrees in a circle. So if we add up that A, B, and C, we should get 360 degrees. If you need a moment to copy it down, you can take a moment to copy it down, because yes, again, I am moving on, so hit pause if you need it. Alright, so our last two angles we're going to talk about, I promise, complementary complementary and supplementary angles. Again, I hope you talked about these before, but if not, here's a little refresher. Let's take a look here. Let's look at the diagram for a complementary angle. Let's see here. This is the usual diagram we see of a complementary angle. Let's see if we can notice some things. Here is one angle, it's 30 degrees. Another angle right here is 60 degrees. So my first question to think about, are those adjacent angles? Are they vertical angles? Are they angles on a line? Are they angles at a point? I hope you notice those are adjacent angles. Again, because they're right next to each other. They share a common side. That common side would be this guy right here. And what do you notice about complementary angles here? 30 degrees and 60 degrees. What do they add up to? So I hope you notice that they equal 90 degrees. Again, here's another example. Right here, 30 and 60 degrees, and again, that gives you 90 degrees. So a complementary angle will always give you 90 degrees. Let's take a look at the definition. If the sum of the measurements of two angles is 90 degrees, then the angles are called complementary. Each angle is called a complement of the other. Take a couple seconds to copy that down. If you need to, you might want to pause the video right now because I'm going to jump into supplementary angles. So supplementary angles, let's take a look at the classic example right up here. We have two angles. We have 120 degrees. We also have a 60-degree angle. So again, let's take a look. Supplementary angles. Are they adjacent angles? Are they vertical angles? Are they angles on a line? Are they angles at a point? Okay, it's actually a trick question. I hope you realize it's actually two of them. They're actually adjacent angles, because again, they share that common side. But they're also angles on a line. And here's our line again right here. So what we learned about angles on a line is that if we add up the angles, it gives 180 degrees. And that's all that a supplementary angle is. Okay, let's look down here. Another example of it, 120 plus 60 give us 180 degrees. So any two angles on that line will give us 180 degrees if we split it. And here's our definition. If the sum of the measurements of two angles is 180 degrees, then the angles are called supplementary. Each angle is called a supplement of each other. So again, complementary angles are 90 degrees, supplementary are 180. Supplementary, how I remember it's 180 is because supplementary starts with an S. Supplementary angles are usually found on a straight line, and a straight line, as we noticed before, angles on the line are 180 degrees. So supplementary straight, 180. If you need to pause the video, now's the time to do it. Okay, so I want you to try this by yourself. As it says 4 minutes. Don't try any more than 4 minutes. If you can't get it, then we'll go over it tomorrow at the beginning of class. So I want you to try to set up and solve an equation. That's important. An equation has a what in it? An equal sign. So I need to have an equation. Make sure you understand the relevant angle relationship also going on. If you don't know the angle relationship, you might want to go back up and look at your definitions. Is it complementary? Is it complementary? Are they adjacent angles, vertical angles, angles on a line, angles on a point? All right, I want you to try that. So, that complete sentence describe the relevant angle relationships in the diagram. Then write an equation for the angle relationship shown in the figure and solve for x. And can confirm your answers by measuring the angle of the protractor if you have one. Alright, this will be the first problem we go over tomorrow in class. If you don't get it, that's okay, but I would like to see you try. Hope you enjoyed the first video. We will do it again tomorrow. Good luck, guys. See you tomorrow in class.